Here's our Unit 6 review video. We're starting off by solving these quadratic equations by graphing, okay? Now, we know, using our calculator, this is our key, that to solve any equation that we want, we could just graph y equals the left side and y equals the right side and find their intersections. We kind of talked about this back in the absolute value unit. So you could graph x squared plus 6x, and you could graph y equals -8. And we could see there's two intersections, which means there's going to be two solutions. Second calc intersect. Again, I got second, calculate, intersect is 5. I'll find the intersection. I'll find the x coordinate that will produce a y coordinate of -8. My answer is not going to be -8. Okay, that's when y is -8. It's when x is -2, this will be -8. So that's one of my answers. And then I'll go second calc, intersect. It's very important. You will travel to the intersection first, after you press second calc intersect. A lot of people will travel like first and then press second calc intersect, but get to your other intersection, enter, 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 and you get your other solution. However, you could have, and this is what we'll have to do for all quadratics other than graphing, add 8 to both sides. Now when you add 8 to both sides, you get x squared plus 6x plus 8 equals 0. You could have graphed y equals x squared plus 6x plus 8, as well as y equals 0, and you would have found the same solutions. Just showing you there are two different ways to do it. Sometimes one way is necessary, sometimes this way is necessary to be able to visually see, because sometimes our y equals one side and our y equals other side will be off the graph. So, but just confirming, there's -2. Now the y is 0. That's not our solution. It's when x is -2, my y's are 0. And the other one, -4. Okay, so same deal, same answers. You could do for any of these equations, either graph y equals the left side, y equals the right side, or maybe move everything to one side and set it equal to 0. If I subtract 6x and add 9, I'll get x squared minus 6x plus 9 equals 0. Y equals x squared minus 6x plus 9, y equals 0. Find their intersections. I'll show you both again. Here, 6x minus 9 is a line, x squared, parabola. And it's kind of tough to kind of see what's going on here. Maybe you could like adjust your window, maybe zoom out. It looks like maybe there's 2, maybe there's 1, I don't know. Like for this one, it's tough to see. Let's see. Enter, enter, enter. Looks like it's close to 3, but it's not exactly like 3, 9. So maybe I don't like trust this way. Maybe I go ahead and graph the other way. X squared minus 6x plus 9 and 0. Go back to zoom standard. Zoom standard. Oh, and you can see, oh, okay, it looks like we're going to have one intersection or 1, 0 here at the vertex at x equals 3. Now, it's not exactly 3. That's because all your calculator can do is like do its best that it can to find these answers. So, if you see numbers very, very close to whole numbers, you can go ahead and assume, at least in this class, that the answer is the whole number that it's close to. Okay, so there's just one answer. There's not a second one. That's why I crossed this off. Let's look at this third one. All right, so we could either have 3x squared and then 12x minus 14, or maybe subtract 12x, add 14, you get 3x squared minus 12x minus 14 equal to 0. So one side, the other side. Let's see, let's try both ways. Maybe one way will be easier to visually see than the other. Yeah, it's like I can't really see it here. I could zoom out, but it might be tough. Why don't we go and switch over to 3x squared minus 12x minus 14 and 0. And like that's a lot easier to see. Oh my goodness, I made a mistake. Should be adding 14. My apologies. So this should be a plus 14. Oh, doesn't look like it intersects at all. Now, if we get to this situation where they don't look like they intersect, we do have solutions, but the solutions are going to be imaginary. There's no way to find imaginary solutions using your calculator. Like if we had zoomed out and you tried to find the intersection, second calc intersect, we would see, nope, no sign change. That means there's no solution. So we would say no real solution. You would need to complete the square or a quadratic formula to find your imaginary solutions. I can do that really quick. ABC, x equals the opposite of b, all over 2 times a, plus or minus the square root of b squared. So that'll be negative 12 squared. We know that is going to be a positive number. Minus 4 times a times c. And I get root negative 24 all over 2a. So this is 2 plus or minus root 24. The biggest perfect square that goes into 24 is 4. So that's root 4, root 6, root negative 1 over 6. This is 2 plus or minus 2 root 6i over 6, or 2 plus, I can cancel the 2 and the 6, creates 1/3, root 6i over 3, and 2 minus root 6i over 3. Okay. So there you go. Next step, we learned how to solve by factoring. Here, 2 terms share a 3x that you could divide out. This is factoring by greatest common factor. 3x divided out of 3x squared, I just have x left over. 3x divided out of 12x, 12 divided by 3 is 4. X with the x pulled out, I'm just going to have that negative 4. Now we're going to use the zero product property that says like which numbers will make this product equal to 0. Well, this, if this was 0, it would make the entire thing 0. And that makes sense. 3 times 0 minus 0 is 0. So 0 is a solution. The other one is 4. 4 squared is 16. 16 times 3 minus 12 times 4 would equal 0. So that gave us 0. This is how I would solve by factoring. This is a difference of squares. It's similar to like x squared minus 4. If I asked you to factor this, you could do it, first of all, by rewriting it like this and saying, what are the two numbers that add to get 0 and multiply to get -4 that are positive 2 and negative 2? Or if you went back to the original, you had said, well, x being squared is x squared, and 2 being squared is -4. X plus 2, x minus 2, difference of perfect squares. This is 3x being squared. This is 7 being squared. I actually could write this as 3x plus 7 and 3x minus 7. Now in this situation, which one of these, what numbers would make these 0? It's not obvious. So I would just solve these two equations where they're equal to 0. Subtract 7 divided by 3. I get -7/3. Add 7 divided by 3. I'd get +7/3. Okay. These are our bread and butter ones. Got an x squared. There's no term that comes before x squared. There's no a. We know that x plus a number times x plus another number when I distribute is x squared plus 3x plus 2x plus 6, which is x squared plus 5x plus 6. So notice this 5 comes from adding the 2 and the 3. This 6 comes from multiplying the 2 and the 3. Understanding distribution, going backwards, all we need to find is the two numbers that add to get 10 and multiply to get 24, and know that my factored form would be x plus something times x plus something else. The two numbers that add to get 10 and multiply to get 24 are 6 and 4. Now my answers are not 6 and 4, because if I plugged in 6, this would not be 0. My answers would be -6 and -4, because plugging in -6 would make this 0. Plugging in -4 would make this equal to 0. All right. Now this guy, we would start off, if we were forced to factor, by moving everything onto one side. Now, let's remind ourselves, let me come back to this one. Let's go to number 8. This is the same deal. What two numbers add to get -5 and multiply to get 6? These are the easy ones. -3 and -2. Now my answers are not -3 and -2 because when you plug in 3, you get 0, which makes everything 0. When you plug in 2, you get 0, which makes everything 0. Great. So those are two of the easy ones. We got to make sure we do these. Now this, a lot of us struggle in factoring. I will remind you. We end up really going through every single step of backwards distributing. Now what we have to do to understand that my first term is not x plus and x plus, it could be like 6x and x, it could be 3x and 2x. Because of that, and when I multiply things through to distribute, we need to kind of factor that in. What we do is we multiply a by c. A times c is -36. B is 5. We are going to find the two numbers that add to get b and multiply to get a times c. Once we find those two numbers, we are going to split this into two different terms. We could have done it for the previous ones, but it's just not necessary. Now I'm thinking it's not 6 and 6. $36, 9. It's got to be 9 and 4. 9 and 4. So it's got to be a +9 and a -4. Okay, so 9 and -4. I'd advise you to put the negative number first. Now notice I'm going to rewrite it as a sum of x's. I have two groups of 2, which I will factor by greatest common factor. What is the largest thing that you can pull out? 6x squared and negative 4x. 2x. That'd give me 3x plus negative 2. Keep this plus sign. What was the largest thing you could pull out of 9x and negative 6? A 3. Giving me 2x plus negative 2. Now, 3x plus negative 2. Now, I see 3x plus negative 2 and 3x plus negative 2. This is good. That means you could factor out. This needs to be the same as this. If they're not the same, you need to go back and try to see if you can change what you pull out. Sometimes you can pull out a 1. Sometimes you can pull out a negative 1 to make sure that these are the same. Because you could pull out this 3x plus negative 2 and this 2x plus 3. And the 2x plus 3 is what's left over. All right, now that it's factored, we can find the solutions by taking both of these pieces, since they are a product, and seeing when they equal 0. So I have 3x minus 2 equals 0. I'll add 2, divide by 3, I get 2/3. And then I have 2x plus 3 equals 0. I'll subtract 3, divide by 2, I'll have negative 3/2. Now, another thing we could do is go back to graphing, make sure that your answers are correct. 6x squared plus 5x and 6, we should be able to see. Let's zoom standard. This is going to be at negative 3/2. Enter, enter, enter. Yep. Negative 3/2 is the same as negative 1/2. And then this will be at 2/3. If I just plug in 2/3, I can see there's the intersection there. Okay, and we can find that using the intersection. So you can always check using your calculator. Let's try another one. Subtract the 11x. I have 12x squared minus 11x minus 5. To completely undo distribution, start by multiplying a and c. 12 times negative 5 would be negative 60. B is negative 11. Two numbers that add to get negative 16, add to get negative 11 and multiply to get 60. 6 and 10 are the first ones that come to mind, but that doesn't work. So let's see, 60 divided by 5. 12 and 5, that doesn't work. 20 doesn't work. Four, 15 and 4. It's tricky. So negative 15 times 4 gives us 60. Negative 15 plus 4 gives us 11. I just started dividing 60 by a bunch of numbers until I found which one works out well. Okay, now, I like using plus and negatives, so I advise you to do that. Negative 11x, you could change into negative 15x and positive 4x. We are ready to factor two groups of 2. This is factoring by grouping. What can you factor out of these first two terms? At most a 3 and an x, giving me 4x plus negative 5. I see this is 4x plus negative 5 already. Well, make sure you know that a 1 can be pulled out of that. So you realize that you'll have 4x plus negative 5 and then 3x plus 1, not just 3x. that's equal to 0, we can go ahead and find when 4x minus 5 equals 0 and when 3x plus 1 equals 0. Add 5, divide by 4, x equals 5/4. Subtract 1, divide by 3. X equals negative 1/3. You can confirm that using graphing. Okay. All right, so that's factoring. Now we have situations where if I have just x squareds and numbers, I could square root. Actually, if you went back to this one, instead of factoring, we could have solved by using square roots, by just getting the x squared on one side, the number on the other side, square rooting both sides, understanding that square root of 25 is just 5, but the original value x could have been a positive or a negative, which is why we write that x could be positive or negative 5. We usually skip this step and go straight here, just making sure you got negative 5 being squared is 25 and positive 5 being squared, which is 25. Now, if it's something other than just x squared, after square rooting, understanding you have a plus or minus 4, make sure you know that you would add 9 to both sides. Now, don't add 9 to the 4 because it's positive 4 or negative 4, and it's not going to be positive or negative 13. Instead, you'd have 9 plus or minus 4. Well, 9 plus 4 is 13, yes, but 9 minus 4 is not negative 13. 9 minus 4 is 5. So that's our second answer. If you have things that could be isolating the x squared first, go ahead and do it. I add 45 to isolate this x squared. Then I square root, and x equals plus or minus root 45. Now I'm going to want to try to simplify this. Root 45, the biggest perfect square is 9. 9 times 5, the square root of 9 is 3. You would write this as plus or minus 3 root 5. For 13, isolate your x plus 4 squared by dividing by 2 first. Now when I divide by 2, I get x plus 4 squared equals 40. I'm ready to square root. I'll get x plus 4 equals plus or minus root 40. Try to find the largest perfect square. Remember, perfect squares are 4, 9, 16, 25, 36, 49, etc. Biggest perfect square that goes into 40 is 4. So I'd write this as x plus 4 equals plus or minus root 4 root 10. That's 2 root 10. I would then subtract 4 or add negative 4 to both sides. I always tell you to add the opposite because you can now write this as negative 4 plus or minus 2 root 10. You cannot add a 4 or a negative 4 to a radical. You can't say this is negative 2 root 10s. You can't say this is negative 6 root 10s. You just leave it like this. You have 2 answers. These are our 2 answers. Okay, so this guy, I'm going to isolate the x squared by adding 7. Negative 119 plus 7. Negative 112. Negative 112 divided by 4 is negative 28. Square root x equals plus or minus square root of negative 28. Now this is when we understand that you can't take the square root of a negative. If you typed in the square root of a negative into your calculator, it'd say, no, I can't do that. It's not real. So when we start talking about the concept of an imaginary number. we write that the square root of -1 is I. That way you know I squared is -1. That will help you if I plugged in something like I. That's going to help us get a negative number, which will give us this negative right side. So what we do is we see if we can simplify this as a positive 28 and a -1. Pull out the -1. That's going to turn into I. 28 I know is root 4 times root 7. That's the biggest perfect square that goes into 28. And this is how I'm going to get my answers. X is equal to plus or minus 2 root 7I. Okay? That is new to us, the concept of an imaginary number. But you plug that into this, you get a solution. Okay, let's see. This one would not be like that. I would subtract 2 first. Get 4 times x minus 1 squared equals 8. I would divide by 4. And I get 2. Make sure you get 2 and not 4, right? You got 8 divided by 4. 8 divided by 4 is 2. Square root both sides, x minus 1 equals plus or minus root 2. Add 1, x is equal to 1 plus or minus root 2. Okay, you can leave it like this. This is fine. Okay, great. So this is using square roots. We saw some imaginary answers. We need to be ready for that. We complete the square as well. Completing the square is a great technique. You can solve any quadratic. Now, I'm going to tell you right away. If you can factor something, go ahead and factor it. If you can find 2 numbers that add to get -4 and multiply to get 12, go for it. Now I think about it. Oh, 6 and 2, maybe that'll work. But it'd have to be -6 and +2. And -6 and +2 do not multiply to get 12. Okay, so can't factor. Instead, we're going to complete the square. This is how we complete the square. We start by getting rid of our number. The next step is to add both sides by a number that would make this a perfect square. I know that if I take x minus 2 and square it, I would get x squared minus 4x. But then I'd have a plus 4. That means I need to add 4 to both sides to give us a perfect square. Another way to understand where this number comes from is to take b, divide it by 2, and square it. b is -4. -4 divided by 2 is -2. And squared, it's going to be +4. So -4 divided by 2 squared, 4. That's why I know I'm going to add 4. The reason why we do this is because this is now x minus 2 squared. How do I know that it's x minus 2 squared? 2 numbers that add to get -4 and multiply to get +4. -2 and -2. So I can write this as x minus 2 times x minus 2. And that can be written as x minus 2 squared. Over here, -12 plus 4, that's -8. I'm ready to square root both sides, but on the right side, I'm going to get a plus or minus root -8. Root -8 is root 4 root 2 root -1. That's going to be 2 root 2i. X minus 2 equals plus or minus 2 root 2i. I will finish off by adding 2 to both sides. We'll add in front of the plus or minus because you cannot add 2 to 2 root 2. So I get 2 plus or minus 2 root 2i. Okay, let's try it again. Start by adding the number, move it to the other side. Find the number that would complete the square. Take b, divide it by 2, square it. 16. Now, this factors to be x plus 4 times x plus 4. The two numbers that add to get 8 and multiply to get 16 are 4 and 4. So this turns into x plus 4 squared. This is 31. Square root. You cannot simplify the square root of 31. There are no perfect squares that go into it. That's not 31, that's 21. 21's factors are 7 and 3. None of those help us out. So I would just finish off by adding a negative 4. Get x equals negative 4 plus or minus root 21. Let's do another one. Subtract 16, or add negative 16. X squared minus 3x equals negative 16. Take b divided by 2, square it. It ends up being 9/4. That's not nice, but it is a perfect square. It is x minus 3 over 2 squared. And on the right side, we could do negative 16 plus 9/4. We could turn it into a fraction, negative 55/4, or we could leave it as a decimal. It doesn't matter. Square root, not pretty, but we can actually simplify this 55/4 and this negative 1. We got 11 and 5. It doesn't help us. But the square root of 4 you can take. I could write this as root 55 over root 4, and then this is I. This is a plus or minus, so this is plus or minus root 55 over 2I. Add the 3 halves to finish it off. This is a tricky one for sure. I wouldn't expect something like this on the on-level test, where we had a fraction used to complete the square.